Hi everyone and welcome to Smart Alex Coaching. We offer mathematics tutoring for primary and high school students, both online and face-to-face. In this video, we're going to look at how to sketch polynomial functions. A polynomial is an algebraic expression consisting of terms in the form of a times x to the power of n. The constants a can be rational or irrational. The powers of x, n need to be positive integers. Polynomials can also be expressed in factorized form as follows. Polynomials of degree n will have at most n roots, x1, x2, x3, all the way to xn. These roots are not necessarily distinct. They can be repeated roots, and the roots may be either real or complex. When sketching polynomials, there are three things we need to consider. First is the location of the roots. This can be obtained by solving p of x equal to 0. Second is the nature of the root. If a root has odd multiplicity, the curve will cross the x-axis, sometimes with a kink. If a root has even multiplicity, the curve will simply touch the x-axis. The leading term and its coefficient will determine the behavior of the polynomial function as x approaches positive and negative infinity. Let's look at example 1. Here I have a polynomial with all three distinct roots. The roots can be obtained by solving p of x is equal to 0. By doing that, I'm going to get three roots at x is equal to 4, x is equal to 5, and x is equal to minus 2. These are all single roots. So my curve will simply cut the x-axis at those particular values of x, marking it on the diagram 4, 5, and minus 2. Looking at the leading term of this polynomial is going to be x cubed. What that means is as x approaches positive infinity, y will also approach positive infinity. As x approaches negative infinity, y also approaches negative infinity as well. Putting all those information together, this is what my curve is going to look like, cutting it at 5, again at 4, and again at minus 2. And as you can see, as x approaches positive infinity, y approaches positive infinity as well. As x approaches negative infinity, y also approaches negative infinity. In example 2, I now have a repeated even root. By solving p of x is equal to 0, I'm going to get roots at x is equal to 2. This is a repeated even root. I'm also going to get two single roots at x is equal to minus 4 and x is equal to minus 6. So these are going to be my single roots, marking it on the diagram at 2, at minus 4, and minus 6. The leading term of this polynomial is going to be x to the power of 4. So as x approaches positive infinity, y will also approach positive infinity. As x approaches negative infinity, y will still approach positive infinity. Putting everything all together, my curve will touch the x-axis at positive 2. Then it's going to cross at minus 4 and again at minus 6. And as you can see, when x approaches positive infinity, y approaches positive infinity. When x approaches negative infinity, my curve will approach y going towards infinity. In example 3, I now have a repeated odd root equating p of x to 0. I'm going to get roots at x is equal to 0. This is a triple root. And I'm going to get a kink in the diagram. And at x is equal to 3 and x is equal to minus 2, these are the single roots. Marking it on the diagram again. There's a root at the origin, x is equal to 0, at 3, and at x is equal to minus 2. Looking at the leading term of p of x is going to be x to the 5. When x approaches positive infinity, y will approach positive infinity. When x approaches negative infinity, y will approach negative infinity as well. Putting all those together, I have a single root at 3. So my polynomial will just cut the x-axis at 3. Having a triple root at x is equal to 0 means I'm going to cut it, but this time with a kink, and then cutting it again at x is equal to minus 2. Observing that as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity as well. In the next example 4, I have a combination of an even root and an odd root. Again, solving for p of x is equal to 0, I'm going to get a root at x is equal to 0. This is going to be an even root with multiplicity 2. I'm going to get a triple root at x is equal to minus 6. And at x is equal to 2, I'm just going to get a single root. Marking it on the diagram first, at 0, at minus 6, and at 2. The leading term for p of x is going to be x to the power of 6. So when x approaches positive infinity, y will approach positive infinity. When x approaches negative infinity, y will still approach positive infinity. Putting everything together, I'm going to cut the curve at x is equal to 2, and at x is equal to 0, I have an even root, so I'm just going to touch at x is equal to 0. And since I've got a triple root at x is equal to minus 6, I'm going to cross it, but with a kink. And as we can see, as x approaches positive infinity and as x approaches negative infinity, in both cases, my curve approaches y going towards infinity. In the last example here, I have a polynomial with a negative coefficient in the leading term. Solving for p of x is equal to 0, I'm going to get roots at x is equal to 1, which is a single root, x is equal to minus 4, another single root, and at x is equal to 3, I have an even root. Okay, marking those on the diagram first, 1, minus 4, and at 3. Now let's look at the leading term for this one. The leading term for this polynomial is going to be minus 5x to the power 4. That means when x approaches positive infinity, y will approach negative infinity. As x approaches negative infinity, y will still approach negative infinity. And this is due to the negative effect of the coefficient of the leading term. Let's put all these together. I've got an even root at x is equal to 3, so my curve will touch at x is equal to 3. I've got a single root at 1 and minus 4, so I'm going to cut in both locations, and this is going to be my curve. And as you see, in both cases, when x approaches positive and negative infinity, y approaches negative infinity. Thank you for watching this video, and I hope that you like it. If you do like it, please share it and do consider subscribing. We'll be bringing you more of these maths videos. But until then, enjoy, and I'll see you next time.